Hello and welcome, my name is Ryan, I'm also known as Rm2kdev. In this video I just wanted to show you guys this 3D printer. This is a little bit of a review of the product. There is no brand, it's just a generic sort of Chinese one. I think it might be CT3 or CTC. It's just a generic 3D printer from eBay that I purchased. I believe it was about $150 US. The seller was awesome. He was in constant contact. He gave me shipping information, estimated arrival dates, that sort of thing. There was no instructions in the box, but the seller pointed me to the GEETech instructions. Apparently this is essentially just a clone of the GEETech. That's GEETech, I think. So I wanted to go over a few things: the good, the bad, the horrendously ugly, the cable mess, and just an outline of my overall thoughts with it. The only thing I've printed so far is this calibration cube, and as you can see, the print straight out of the box, it's not bad, but it's not great. We've got some issues there. I don't think it's extruding enough filament for the bed. The top surface is quite nice though. It's pretty straight and uniform. The actual layers, if you can see, there's one step, just where my thumb is, where if you look at it sideways, it sort of juts out to the right a little bit, and then the cube sort of goes off in that direction. So I'll just put that down there so we get a better look at it. There you go, so right about there in the middle, the cube sort of heads off in that direction. Now, what I think that is this Z threaded rod, the Z axis. When this rotates, this is actually spinning up in here like this. So this threaded rod is not straight. Now this threaded rod, however, it is straight. But from what I've seen online, there's a lot of people who are suggesting that this carriage mount here, with the way that this threaded rod is connected to it, if there's any wiggle in this, it translates to this entire frame shifting left and right. Not the whole frame, just this assembly shifting left and right. And I think that's what's caused this issue with the calibration cube. Now, we'll get around to printing a 3D benchy eventually, and I'll film that and show you guys. But I figured for the first print we'd do something quick. So the first, let's go over the bad things first, and we'll save the good things for last. So one of the things that I found, I mean, the absolute worst thing is this power supply. I can see that it has this protection here, but first of all, it's obstructing the way. You can't even see it. I've got filament on the desk as well. You can't even see it. You've actually got the plug-in power cable here. These are the wires that power the motherboard, so they're not too bad, but I still would not like to have this resting on here. And the actual power on and off switch is right underneath the, in Australia here, 240 volt, right underneath the 240 volt power connectors, straight from the mains wall socket. And if you have a look down there, you'll see, if I just push this in, I've got the camera on a selfie stick so I can push it into places, but if you see down there, that is the power connector, and it's just got some terminated ends on it, and they come back. I've pushed those back out through here, and then they connect up into here. So in order to turn this thing on, you have to stick your finger up in there and flick the power switch, and that's very close to this mains power here. So I'm going to need to do something about that. I'll probably put some tape over there, just a bit more added protection, but I really don't like that. I think that's very quite scary, actually. Another thing you could possibly do is try flipping the power supply the other way around and then putting all the power connectors at the top. I'm not sure if that's how it was supposed to be done, but in the instructions that I found, that's how they've done it. So the next thing that I'll go over, not a huge issue. A lot of people mention this, but the actual Y-axis end stop, which is this one here, it's too far back. And so when you, if I just get in here, when you push the, I'm going to do this gently because I don't want to generate current and ruin the main board. When you push this back to the point that it actually triggers that end stop, there it is, the actual print head nozzle is off the bed, and so it ends up dribbling hot filament straight down across this rubber belt. Not so good. Easy fix is just to print a little, or even just make a little thing out of wood and stick it on the back there, just to shift that end stop forward a little bit, so that we're not actually ending straight away. We're not ending too far back. Now the next point that I'd like to mention, and this might just be my unit that I got in the box, and it's not a huge issue. I can replace these myself. For the price, I'm still extremely happy with what this is and the quality of all the parts. But if you have a look in here, this is just a small example, but there's actually some rust on these linear bearings. I think it's rust anyway. I'm trying to get my camera to focus on that. They're actually a little bit rusty. That one's not so bad, but the ones on the back of the X carriage, and I've rotated them so that you can't see it very easily, but if you just let me put the camera down in here, and then if I go down like that, you'll see there's a huge rusty patch. The entire back side of this is rusty. So that's one sort of point. Not a huge issue, like I said, these linear linear bearings, they're only a few dollars on eBay. I've already got 5 coming in the mail, so I can replace the ones that are on here. Not a huge issue, but you know, it's worth mentioning. It is there. So now, as I mentioned earlier, these threaded rods, they are, I mean, this one here is not straight, and when it rotates, it actually wobbles left and right. Now that translates, because this is directly attached to this threaded rod, it translates into the X carriage, so the whole carriage shifts left and right, and then you end up with sort of, if you look at the edges of that, you end up with that sort of effect there. So that's one thing worth mentioning. And the other thing, which kind of surprised me, was the couplers. All this came with was some sort of plastic poly tube, and they just stuck it on there. So there isn't I don't know if that's a bad thing or a good thing, but every 3D printer that I've seen online uses like I don't know what you call it. It's like a bushing. It wouldn't be a bushing. It's a coupler. It's like a shaft coupler. Haha. And I'm just kidding. Don't comment about that. But it's a shaft coupler. Essentially, it screws onto this bottom part. It screws onto this top part. It has a bit of a spring in it, and that allows for any tolerances that need to be, you know, with the wiggling of the rods, or if they're off-centered, or you know. But this one just came with some plastic. Not sure I like that. Same for this side here. I haven't had any issues with it yet, but I can just sort of foresee if this gets a little bit hot and it stretches a little bit, maybe we'll end up with some missteps along the Z-axis. I haven't had any problems with it. Yeah, I've only printed this cube here and I've done some basic calibration, but I'm not sure what the longevity of a piece like this is. So again, I've ordered some of those replacement parts on eBay. I think they cost me like $1.50 with free shipping, so not a huge problem. I'll get those changed out, and I'll make some update videos as I do this. You know, so that's going to be one of the issues as well, I think. So another issue, as you can probably see, I've got blue tape, green tape, blue tape, blue tape. Now, the bed originally came with blue tape on it. That's not an issue. I was really thankful that the person actually thought to not only provide the borosilicate glass with the kit for the price, but to also put the tape on there for me. That was quite nice of them. I thought that was really nice. And I'll leave a link to the eBay seller in the description below. But another thing that I didn't quite like about this design, nothing to do with this borosilicate glass or the tape, is this Z end stop, which I've got on here. Now, during my first print, I calibrated the machine. It came down, you know, so I did the manual calibration. You have to do manual adjustment. Now, this comes with some like wing nuts, so you can adjust the height of the bed manually, which is quite nice. But then the Z axis, this was the interesting one. So this was calibrated to stop correctly in the correct position. I adjusted the bed. I used a lot of people online, they say just, you know, get a piece of paper, make sure, fold it in half. It's about 20 millimeters. Sorry, not 20 millimeters. Is it 20 millimeters? That's not 20 millimeters, that's 20 centimeters. What am I talking about? It is, and I can tell you right now, let me just get my calipers on there. it's about 0.2, that's not tightened down because I'm using my left hand, but it's about 0.2 millimeters, there you go. Which is the appropriate depth that you would most likely like to have. Ooh, sorry, my camera just fell off that. Which is the appropriate depth that you'd like to have between the hot end nozzle and the bed. Now, that was all good, that worked fine, and during my first print, these nuts came loose. Now, that doesn't mean anything for the print that's happening, but given the second print that I did, which is just another calibration cube test, the first thing that happened is the 200-degree hot end and nozzle just came crashing down into the borosilicate glass. It pushed it right down, and I didn't realize that that was what the problem was. So meanwhile, I'm over here on my laptop going, abort, 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 and this thing over here is just like wrecking its way through the glass. So be careful of the Z-axis end stops. They need to be tightened down really tightly. I'm going to print another part to replace this, hopefully with a little better support and maybe some locking nuts instead of just, you know, just regular nuts. The worst kind. No, I'm just kidding, I don't know. But, you know, it would be nice if that part there didn't fail from the vibrations during the first print, causing the hot end and nozzle to come crashing down into a piece of glass. I'm not sure if that would cause any damage. In my case, it didn't. It was just a little worrying that the 200-degree nozzle was, you know, pressing down with quite a bit of force, enough to sort of warp this plate, pushing it down and cause these springs to compress a little bit into there, and that's why I've replaced that tape. So those are a couple of the bad things. Nothing really bad per se. It's nothing that can't be fixed. It's nothing that can't be adjusted. It's nothing that can't be changed. It's certainly part of the fun of having a 3D printer, I think, and that's going to be the challenges to overcome moving forward. But let's move on to some of the good things, some of the things that I really like about this design. So the first one, I guess, I mean, it was extreme. I mean, this is not really a super nice thing, but it was nice of them to include some cable management. You know, you've got your hot end down here, you've got your power for that, you've got your thermistor for checking the temperature, fan, you know, you've got your motor, your stepper driver cable. You know, it's nice that they've included some cable management, some cable strapping, I don't know what you call that, but it just sort of cleans it up. I will cable tie this like that just to keep those cables out of the way, but that's a nice little inclusion. The LCD screen, very nice. Very nice. It does the job. Got this little rotary encoder which lets you select, and that's notched. So if I get right up on that, you'll see it's notched. So it's not just freely spinning. It actually has like tactile, rotational. I don't know what the word is. It has some feedback when you turn it, so you know what's happening. Now, the screen itself is adjustable. There is like a little pot here on the back. Now, I mean, the soldering on this is not fantastic, but it's there, and you can adjust that to calibrate the contrast of the screen. Another thing that I really like that I've just noticed, it uses a full-sized SD card. So, you know, a few people have mentioned that, you know, it sucks, you know, if you have a micro SD in here because, you know, it's fiddly to get in, and that's true, and you might lose it during prints and all that sort of stuff. And I mean, the chances of you losing the SD card from, you know, computer to printer is very low, but the fact that it uses a full-size SD is really nice. You can get your hands on it, you can pull it out, push it in, no problems. You don't have to find the thing. It's just nicer to have that. So that's one thing. Something that I really like about this is the actual board, the motherboard itself, the heart of the 3D printer. This is the GEETech 2560 board, and this board, part of the reasons that I like it is it uses the upgraded Arduino, the AT, is it 18 mega? I think it's 18 mega 2560. I'll correct that if I'm wrong, but it's an upgraded chip over just the standard Arduino board, and it contains everything you need embedded. So there's no shield that goes on top. It's just one board, and the parts that need to be replaceable, for instance, these stepper motor drivers, if these blow, you know, for instance, you know, I'm being stupid moving the board really fast, generates a voltage and it spikes, and it, you know, causes a, I don't know what you call it, a surge in one of these, and it blows one of the chips. You just pull these off the board. They're just on sockets down there. I don't know if you can see that. Let me get a little pointer. It's just on sockets down in there. And you can just pop them off and replace them with new ones from eBay. They're like 50 cents each, so that's nice. Some of the other boards that I've seen, these are integrated, so if you blow a stepper motor driver, you're basically screwed. Buy a whole new board. Again, the whole board's only like 12 bucks, but still, that's nice. Excuse me. I don't know what you call these. They're not DuPont connectors, I don't think. Anyway, the actual connectors, they came pre-terminated with these, so you can just plug them in, off you go. It's got nice big heat sinks in there. I like the fact that there's actually a fan here, which I'm aware I've wired it in the wrong way. Silly me, but there's a fan back there. I don't know if you see that. And essentially, what that's supposed to do is suck air in from the front here and just blow a nice cold stream of air over that board just to keep it cool if it does get a little warm during operation. It actually, I haven't noticed it getting warm. I've had it on for a few hours while I was calibrating. Didn't get warm at all, but you know, it's nice that the option is there. So one of the things that I've done is I've added just some, I don't know what you call them, bulldog clips, I think they're called in Australia, as a little bit of cable management. I mean, it's not fantastic, but, you know, it gets the job done. It hangs the cables. I've also used a bulldog clip up here, you probably saw it earlier, as a filament guide, as it didn't come with a filament guide, but you kind of do need one, because otherwise the filament gets stuck in this gap under here. And that's, I mean, I should just loosen these screws and close that gap, but it's nice to have a guide on there. I mentioned earlier the fact that it came with the borosilicate glass and the clips, which is nice. One of those things, you know, it came with. Most of the cables, which was really nice, came, if you have a look down there, there's this is my main power lead, came wrapped in heat shrink tubing. Again, that was nice. The inclusion of the cable strapping, I guess, was nice. Everything relatively useful about the printer was nice. It was quite good. I did have some issues getting this hot end assembly, I don't know what you call that, the gantry, I think it might be called, attached to this X carriage, just because if you have a look down in there, the screws are quite far back now. Of course, the instructions suggest, oops, I think I just scraped the camera lens on the corner of that metal. If you have a look at the back, I've got these really long screws in here. The only screws that this machine came with are these long ones and then the shorter ones. Now I can show you an example of the shorter ones. There's one of the shorter ones, and if I hold that up in line, you'll see, well, you probably can't see that, you know, it barely goes through that plate. So with the short plugs in there, there wasn't enough room to stick the bolts down in here and get it in, and of course the instructions suggest putting the screw in this way and the bolt in this side. Now that didn't work for me, so what I've done is I put the screw in. I had to take this whole hot end apart, put it in separately, put the screw in this side going that way, and then the bolts on the back in there just to hold it in. And I had to use the long ones because there was no other option. But, you know, not a huge problem. You can get that out of the way quite easily. But the point that I was going to make about this is actually quite a nice setup. It's very simple. You can take this apart. I will be upgrading this with a Bowden extruder once the parts arrive. I have a Chinese clone of a E3D V6. If that is any good, I'll upgrade to a genuine E3D V6. If it's any better than what's on here, and I don't know what these are called, I'm just going to call this a standard extruder. I don't have a proper name for it, I'm sorry. But that's quite nice. So, very simple part. You can just unscrew this, this pops off, take this bracket off, print a new one, put it on there, put anything you like on this end here. Very easy to work with. Something else I like is the fact that the shell is made out of plywood. Now, it's not a very good quality plywood. Excuse me. It's only 5 layers, I think. I'm counting that right, yeah. 5-layer plywood. Not the greatest stuff. I expect this is going to get some warping when we get some humidity, when the print bed heats up, when the hot end heats up, when the unit cools down, and all of that is going to translate into movement, which is going to translate into the what would you call that? the invalidation of the calibration. No, I'm kidding. that might work, but in English, but that's what I mean, but that's a terrible way of saying it. It basically would just mean that everything is going to get out of calibration as this expands and contracts during use. I don't think it's going to be that much of a problem. I do like the fact that it's just got the added rigidity of It's got the added rigidity. I can't even say that word. So another thing that I like is the fact that it's come with these wing nuts on here. You see some of the 3D printers, they'll have a nut down here underneath. Sorry, not a wing nut, just a regular nut. Maybe a washer and a nut on here, a spring, and then a screw. And you basically just put a screwdriver on top to adjust the bed height. This is really simple. You just come down here and grab and twist these. Don't need to have any tools with you to operate it, to calibrate the bed, but you know, it's just a nice little feature that they've got on there. I do have all the tools out because I've obviously just finished building this, so the desk is a mess. I apologize for that. Something else quite nice is it's got these belt tensioners. Basically, it's just a screw you can tighten and loosen, which will adjust the tension on these belts. And again, you have the same thing for the X axis as well. So you've got X adjustment and Y adjustment. You don't need it for the Z adjustment because there's no belt on Z. But that is a nice little feature of the 3D printer. They supplied an ample number of cable ties. I've used heaps of these. I've got cable ties here, here, here. I've cable tied everything as neatly and nicely as I possibly could. I will come back and I'll start to sort of mount. I'll put some like mounting clips. I might just do this again, some more bulldog clips along the frame, and just sort of tidy up those cables a little bit. I like the fact it uses a full-size USB. You basically just have access to USB port, and that it's not on the bottom. Some of the 3D printers, they have the USB port under here, and you've got to like fiddle around trying to get that in there. None of that with this thing. Just a nice plug straight on the top. It came with an ample number of supplies, washers, nuts, screws, even the small screws. Basically, everywhere it said to use these small screws, they didn't fit, so you had to use the long ones. But because it came with so many, beautiful. One thing it didn't come with, and I just remembered, I can show you now. If you have a look down under here, and you see this, I'm just going to stick that in there. See that bolt just up on there? That one there? The little carriage there, and then the bolt behind it. Those are M10 nuts, M10 washers, and then there's like a joiner, I guess, and the joiner connects to the solid frame, which basically allows you to align the Y-axis onto the frame. It didn't come with these bolts, so I had to go down to the hardware store and buy those. They cost me $3, I think. I bought more than I needed. I bought backups just in case I needed to replace them, so I think I got about 8 nuts, 8 bolts, 8 nuts, 8 washers, and it cost me like $3. So could have bought those on eBay, but I didn't want to wait 2 weeks for them to arrive. So that's that. Excuse me. The assembly for the belts, it's attached with zip ties. I don't know how nice that is, but we might print something off to solve that problem. I think that's really all I have to say about this printer. A little bit of dog hair on there. Overall, very nice printer. One more thing that was very nice. It came with this 3D printed spool holder. So it came with a kilo of yellow PLA, which is nice as well. So included in that price was a kilo of filament to print with, and the spool holder, as well as the 3D printer, as well as all the upgrades like the borosilicate glass, the upgraded Arduino board, the screen, the SD slot. It just came with everything, even the tensioning adjustments. I mean, some of the printers don't come with anything like that. You have to upgrade it all yourself once you've got it to print it out. And what I'll do is I'll just power it on. Just like use this suicide plug. I'm going to call it a suicide plug from now on. That's why I don't like that. Just so you can see the quality of that screen. I'm just going to shut my curtain. Turn the light down because you got some light reflections in the lens when I do that. Let me shut that curtain. There we go. And just look at the quality of that screen. I don't know if you can see that, if that translates through camera very well. Let me back off a little bit. The screen is extremely good quality. It's not translating through the camera, but it's extremely bright. it's very blue. On my camera, it looks kind of purple and washed out. There's no washed out to it at all. It's just really, really bright, really, really blue. Look, my curtain again. So that's nice. Some of the information that it tells you on the screen. Actually, what I'll do is I'll translate some of these, just in case, you know, you've just purchased one of these and you don't know what these options are. We have the hot end temperature currently, so that's this piece down here. Currently around 25, 24 degrees. This is our target temperature. So when you're printing something, it will have the option to say, you know, I want to set the hot end to 200 degrees, and you know, that's where I want to get to, and then it starts heating up. So this is the current temperature, this is the target temperature. When you have a target of 200 and current is 24, this will start to go up, and that means that the hot end is hot. Do not stick your fingers underneath here and touch the hot end, because you will burn yourself. It's very hot. The heated bed, again 25 degrees and target temperature. Then we have the X, the Y, and the Z position values. Then we have the feed rate. So FR is feed. Come on, camera, focus. Focus. Okay, we have feed rate. No, it's not going to do it. Back up a little bit. So FR is feed rate. That's basically the percentage of filament going into the extruder. So a feed rate at 100%. When you ask for 1 millimeter, you get 1 millimeter come through. At 101%, you ask for 1 millimeter, you're going to get 1.01 millimeters. Or I think that works out right. Then we have the SD percentage. So when you're printing something from the SD card, that will increment up to 100%. That's basically just the progress of the print. And then next to that, you have the hours and minutes that the printer has been on. And finally, i3 Pro B ready is a bit of a status. So, for instance, I don't know if this is going to work, but when it's printing, if you trigger an end stop, one of these things, that changes basically to say Z end stop hit, X end stop hit, Y end stop hit, heating bed, bed ready, printing, ... You know, it's just a status update. So, for anyone who's wondering what that means, that's what most of those things mean. And of course, you can push this in and you'll get access to information. We have the prepare menu where you can come in here and you can preheat for PLA or ABS. I wouldn't print ABS on this, to be honest. You need a high temperature bed. These beds, you know, okay, they can get to high temperatures, but it's just gonna, especially if it's a big part, it's just gonna peel up at the edges, start to warp, the print will fail. I'd stick with PLA for these. And I mean, PLA, no one shows this, but this is extremely rigid. I mean, if anyone who hasn't had, I mean, this is the thing that I was wondering before I had a 3D printer. Is this material going to be strong enough to replace things that are broken? And it's extremely good. I think the only issue this has is temperature, is applications where temperature is a problem. So for instance, you can't put this into a place where the temperature is 60 degrees all the time like a car. I mean, cars probably get hotter than that, but you know, it will just melt and go and shred. This is printed with 20% infill. I cannot crush it. That's as hard as I can go. I cannot crush that. If you don't mind looking at my dirty carpet, just please understand that I have dogs and they run around the house and they leave dog hair everywhere. I will do a bit of a torture test with my cube and my rusty hammer. So let me just put that on the cleanest section of carpet I can find. And I mean, that is, let's bring that back up to the bed. That doesn't even have surface damage. I can wipe that damage off. That's how strong these parts are. So that's 20% infill. Now imagine if that was 100% infill. That would be well solid enough to fix things. Anything that needs fixing. Now, most of you are probably wondering, Ryan, why did you get a 3D printer? Why would you even bother? Well, number one, it's kind of cool. I like the idea of being able to print stuff and for the printer to upgrade itself, but I have a use for it. This is a piece from a tripod that my dog broke. Essentially, he ran through it and just pulled the whole tripod over, and then this was the failure mode. So I'm going to be reprinting that probably in yellow and fixing that tripod. So expect a video on that. I will make a video on that, and I mean, you can see why it failed. The manufacturer is trying to be cheap, taking out some of this plastic. save costs, I guess, putting a hole through that centerpiece. I'm going to print that in 100% solid plastic, and we'll repair that tripod. So that's one of the reasons why I bought it. Of course, the giant list of things that you can do with a 3D printer, such as printing useless figures, printing more useless figures, copyright infringement, and all the other wonderful things. I mean, that's quite fun. I was being sarcastic there, in case you didn't realize, but you know, printing off all the miscellaneous stuff will be quite fun. You know, I really like the idea that it upgrades itself. So I'm going to have a video on fixing these Z-wobble things, and that's done with just a little piece that moves across like this. You separate this piece from this piece here, and you allow that to wobble, and essentially you can solve that problem. I'll go into that in detail in another video, but that is the 3D printer, the CTC model number D5282. I don't know. It's basically a Prusa i3 clone, or a GEETech i3 clone. Now, GEETech is a copy of the Prusa. Prusa is the originator of this design, and then GEETech and all of the other Chinese manufacturers copied that, and then whatever this is a copy of the GEETech, because it uses the GEETech motherboard. It actually may be a GEETech from the GEETech factory, just without the branding. I'm not sure any more information than that. It doesn't seem to have any, and there's nothing on the box. The box is just white labeled, so it's possibly just from the GEETech factory. I will leave a link to the product in the description so you can take a look at it yourself. And I hope you've enjoyed this video. I hope you're looking forward to seeing some more videos of the 3D print. I didn't record a time lapse of me building this because there are a million videos online of people building these things, and to be honest, none of them are helpful. There's like I said, you know, issues trying to fix where the hot end mounts to this, and there's a million and one little problems that you have to solve when you assemble this. None of the videos on YouTube were really helpful, partially because they're not indexed. You can't find the assembly instructions for the bit that you're working on easily, so it's not readily available, and partially because everyone does time lapses. So in 14 minutes they've assembled a 5-hour assembly printer, you know, so not useful if you're trying to figure out where a screw goes. And also partially because these pieces are 3D printed, there is a massive variety of different pieces that come with these printers, so you have to put your thinking caps on, solve some of the problems yourself when you assemble it. Not a problem if you are capable in that capacity. If you're not capable in that capacity, probably better off buying a pre-assembled machine. You know, and then there's still a million and one challenges after that, like, you know, calibration and things like that. But, you know, if you really want to get into the 3D printing, then, you know, buy a pre-assembled machine, or if you're capable, buy a machine in parts. I think that's really all I have to say about it. Those were the cons and the pros. Like I said, we'll be upgrading these. There'll be a video on that. I'm going to try and make a few 3D printer videos. I figured that'd just be interesting. I've got my camera here with me now. I haven't had this camera working for a while, so we're back to working now. There's a few upgrades that I want to print. I will definitely have a video of that creation of the part that I've lost. I don't know where it is. Oh, there it is. Creation of this part, and then also the fixing of the telescope. That'll be quite fun. And that will be it. Thank you for watching. I hope you've enjoyed this video and the look at this 3D printer. Please take care, have fun, happy holidays, happy new year. Looking forward to what comes next, Easter. Best of luck for Easter. Pretty random, but anyway, thank you for watching. I hope you've enjoyed it. Please leave a like in the section below, a comment, and subscribe to my YouTube channel for more information on 3D printer game making tutorials, which, by the way, will be coming again soon. So look forward to that once I have some more time to produce some of those tutorials in GMS2. So I hope that sounds appealing. But otherwise, yes, I will talk to you all later. Thanks for watching. Bye for now.